Okay, multiplying. So multiplying, I find a little bit even easier actually. So hopefully this won't be too bad for you. What you do is you really just like if we had like a situation like this, let's say 2m times 5m, is you just treat the 2 and the 5 on their own. So you'd say 2 times 5, and then you go m times m. So in the end, this would be 10m squared. Um, you do the same if they're different, right? Like m and n. So you still go 3 times 4, and then you just go m times n. So we're going to do the same type of thing with our radicals. This part here is just saying that x can't be negative, is what really what all that means. Um, but if we're doing with a radical expression, just ignore that. It's going to be really the same concept. So if I had, I know this looks all confusing up here, but you're really just going to say, okay, m times the n part of it, the coefficients, they get multiplied out front. The underneath here, so a and b, they get multiplied underneath. And that's pretty much it. So if you like to think about it as like pictures, you can think about it as if the dog and the dog get multiplied, the coefficients get multiplied, and the cat, is that a cat or a different type of dog? Anyway, the cat dog and the cat dog get multiplied underneath the radical as well. And that's pretty much it. So only radicals can be multiplied. So if you look at here, we've really just got negative 2 and 5 that are going to be multiplied, our coefficients, so negative 10. And then our radicals, or sorry, our radicands get multiplied, so 7 and 2. 7 times 2 is 14. So you can pretty much do these ones in your head if they're small like that. Don't forget to use something called distributive property. I know you've done this before. You might have heard of it as rainbow. Like you go this one times that one, and then times that one. You might have heard of FOIL before. But this one you wouldn't FOIL, I guess, because there's not two. You would FOIL this type when there's two terms in each one of them. Yeah, but anyway, so what we have to do is go this first 4 times square root 2. We have to multiply that by 3 root 5 first. That's where this comes from. The 4 and the 3 made the 12. The 2 and the 5 made the 10. And then we go 4 times root 2 times the other term, times this one. 4 times negative 2 is negative 8. Root 2 times root 8 is root 16. And then where do we get this from? Why does that look different? Well, if you look at just minus 8 root 16, I don't need to have root 16 written as root 16. I know what the square root of root 16 is. It's 4. So this is really just 8 times 4, which is 32. So I'm going to do letter C over here too, just a little bit different. This is definitely a way of thinking about it, but I'm just going to show you a different way too, the way I would probably do it. So if you had something like this, we need to rainbow it, like I said, rainbow or foil, whatever you think. So it's going to be, anyway, it's got to be the first one times both of them, so 3 times 7, and then 3 times that. And then root 5 times 7, and then root 5 times 2 root 5. So you have to do 4 things is what you do in the end, right? So 3 times 7. Change my pen here. 21. And then 3 times negative 2 root 5. Well, only the 3 and the 2 can be multiplied by each other. That root 5 is just getting like tacked on the end. So this just becomes negative. You have to keep the negative, right? Because there's a negative times this was positive. So negative 6. And then just root 5. That's all it is going to be in the end, just root 5 there. And then root 5 times 7 is the next one. Everything's positive, so it'll be plus. And all I can do there is just rewrite that as 7 root 5. Okay, and then the last one, I've got root 5 times negative 2 root 5. And this one always kind of confuses people. It's going to be negative because I've got a positive times a negative, so it's going to be negative or minus. And now I've got 2 times, well, you could go square root of 25 because 5 times 5 is 25. And then I could think about it and say, okay, I know what the square root of 25 is. That's just 5. Or the other way of thinking about it is that you've got square root of 5 and you're multiplying it by the square root of 5. So really what you're doing here is you're going square root of 5 times square root of 5. You're going square root of 5 squared. Well, the square root of 5 squared is just 5 because the square root and the square like cancel. So that's just 5. So you can think about it both ways. They're both right. So if we kind of clean up what we have here, we've got, here, I'm just going to rewrite this 2 times 5 part. I'm going to rewrite that as 10. Okay, now we just need to collect like terms. So I would say, okay, the 21 and the 10, those are alike. My negative 6 root 5 and 7 root 5 are like. So what I end up with is 21 minus 10, so 11. And then negative 6 plus 7, that's just 1, so that's and positive, so plus root 5. One thing to note here too for, let's say, D, this one is a little bit different, right? Because there's no like adding or subtracting in there as well, right? So if these things are all just kind of like smushed together, that means you're multiplying all of them, and it doesn't matter like which thing comes first, which thing comes second. All you gotta do is grab, like things. So the 4 and the 3 get multiplied together. My x to the 4 and my x to the 2 get multiplied together, but stay under a cube root because it's cube root. And the 16 is just kind of on its own. So go ahead and look through that one for more help there. So I'm going to let you guys go ahead and give this one a try, and then I'll help you out in a minute here. So try A and B, do them both, and then I'll kind of pop the answer up here in a second. So go ahead and pause that now. Okay, so I haven't finished yet. I'm just going to kind of carry on with you guys watching the last part here. Notice with this one, you can kind of see what I did here with the distributive property. And I ended up simplifying this last one down to 6 root 2 just by doing stuff we've done in the last lesson. This one, I went 7 times 7, 7 times root 3, negative root 3 times 7, and then negative root 3 times root 3. And I got these 4 things. Notice that I've got plus or positive 7 root 3 minus 7 root 3. Those cancel, right? Just like you have something and you're minusing the same thing. They just, that's equal to 0. So all I really have here is 49 minus 3. So my answer here is 46. So just a little heads up for future lessons. What this is up here, if I just erase this for a second, this is called a conjugate. So you can see how we've got 7 minus root 3, and then you got 7 plus root 3. That's called a conjugate pair. So it means they're like almost like opposite of each other. And we are going to use that ability to actually cross things out like this. We're going to use that later on just to make things easier. So because you can see, like, you had something pretty complicated and ended up with a simple solution. So things to come. Okay, so that's going to be it for that lesson. Make sure you guys do the homework questions, and that's going to be it for that video.